Additional connectors that we'll see on our computer are going to be our RJ-45 and our RJ-11 connectors. When we talk about our RJ-45, a lot of people may automatically think our internet cable. We have our motherboard here. This port right here is going to be our RJ-45 port. RJ stands for registered jack. And the 45, unfortunately, doesn't help us out with how many wires, how many pins it has. Our RJ-45 only has 8 wires. When we plug in our RJ-45, we'll see that it actually clips in to the jack with a locking clip. These can break and become very irritating, but they are helpful with keeping this cable from just pulling out on its own and make it easy to press and release the cable. When we take a look inside of this cable, which we've already split open, our end actually has several twisted pairs of cables. 4 bundles of 2 wires in each bundle. And as you can see, all of these cables are color-coded. Orange white, blue white, brown white, and green white. These different cables go in different orientations inside of our clip. These different orientations are patterns that allow us to make sure that our cables are either the same on either end or switched over or crossed over, depending on what type of cable we need. The 2 different color patterns we use are T668A and T668B in order to determine our color pattern. Now, when you're plugging a cable into, say, a port in your wall, the color pattern color pattern cable that you're plugging into your wall really doesn't matter, as long as both are the same type of connections. As long as you're plugging a straight through cable into that straight through port, it's okay. The color patterns really just come into play when we're maybe setting a standard for how we're going to wire a certain building, or setting a standard for the types of cables that we're going to set up when we do crossover. So it really just depends on our situation. RJ-45, 8 pins and 8 wires inside of it. And we're going to have our 2 coloring sequences, T668A and T668B. And again, these coloring sequences refer to the colored wires and how we order them inside of our clip. So when we put our wires in our clips, we follow one of these coloring sequences to keep things standard. The RJ-45 cable is referred to as a UTP type cable, which is an unshielded twisted pair. While it does have a plastic coating on it, it's not a shielded coating, and by twisted pair, we already showed how these cables have twists along them. Now, the twisted pairs of cables aren't just twisted in a random fashion. The twists are actually at different lengths along the cables, and the number of twists have to do with helping us to reduce electromagnetic interference. The 2 cables twisted together work together in order to help reduce the amount of interference that we see when we're plugging in the cable and when we're running it over a distance. If we didn't have the twists, there would be a lot more interference, and the cable would have to be a lot less length. So we twist up the cable and we can get a bit more length out of it. This particular cable actually also has a additional plastic rod inside of the cable. All this does is to help make the cable a little sturdier and help to stabilize these twisted pairs. We'll discuss now the actual different types of RJ-45 cables we have. We have Cat3, Cat5, Cat5e, Cat6, and Cat6a. Now, they didn't just start with Cat3. There are other Cat cables, but these are the most familiar cables that you'll be seeing. The other category cables, Cat1, Cat2, Cat7, they may be used by, say, your internet service provider, or when they're putting lines on power lines. But the different categories of those aren't the type of categories of cables we'll most often be working with our local computer or our networks. We'll be working with Cat3 through Cat6a. Cat3 has a maximum throughput of 10 megabits a second, and it runs at 16 megahertz. Cat5 is going to let us push through 100 megabits per second, and we're going to be working at 100 megahertz. Now, this 100 megahertz is what we'll be running at standard. There is another mode that can be run over these lines, which is called asynchronous transfer mode. And in asynchronous transfer mode, we'll be running at 155 megahertz. Now, again, this isn't a type of mode that you would commonly be running on, say, your home computer. This asynchronous transfer mode is a special mode that we can run the data over these cables that we can't route when we're running in this mode, but we can run from one asynchronous transfer mode switch to another, all the way just to a single other asynchronous transfer mode switch. It helps. It's a mode that say internet service providers use in order to help transfer information between distances between those two switches. But again, we can't route any of that data. It's in a special mode, asynchronous transfer mode, ATM for short. Cat5e, also at 100 megabits per second, 100 megahertz. Asynchronous transfer mode, 155 megahertz. Cat5e is a step up from Cat5 if you're trying to, say, wire your house and you're trying to get the best that you can and you're deciding between the two, just because officially their statistics are the same as far as their transfer speeds and their megahertz rates, and as well as their throughput. That's all theoretical. Cat5e, you may see a better performance than Cat5 depending on the environment and the situation that you have it in. So out of the two, if you need to actually get the best, the fastest, and you have to choose between Cat5 and Cat5e, you'll want to go with Cat5e. Cat6, we're going to be looking at a 1 gigabit per second connection, and that's going to actually transfer over at 250 megahertz. When we're running in asynchronous transfer mode over this cable, that's just going to be at 155 megahertz. But again, these megahertz that we'll be using most often will not be these asynchronous transfer mode megahertz. We're going to be running over just the standard. And then the Cat6A is going to be at 10 gigabit per second, and we're going to be pushing at 550 megahertz. Now again, remember, when you're updating your environment, you can't just take new cables and replace the cable going from your computer into the wall and then expect, oh, okay, I upgraded my cable from my computer to the wall from Cat5 to Cat6, and so I'm going to experience a giant boost in internet speed. I'm going from 100 megabits per second to 1 gigabit a second. That's not true. Just because you replace that cable doesn't necessarily mean that that's going to happen. The entire connection that you're going from, say, your internet service provider all the way to you is your transfer speed over the internet, or if you're connecting to another computer in your environment, all the cables and all the switches that go between you and another computer come into play. So just a quick demonstration on your computer. In order to upgrade from, say, a Cat5 speed to a Cat6 speed, you would have to have a upgraded network interface card that supports up to Cat6 speeds. So you'd have to have that. You'd have to have a gigabit internet card. You would have to be using Cat6 cable. So you'd be replacing the cable that goes into your wall. The keystone, the port in the wall, would have to be a gigabit port. So that would have to be replaced as well. Inside the wall, you'd have to make sure that all the cabling supported Cat6. All the way to any switches that were utilized would have to all be, you guessed it, gigabit. Now we're saying Cat6. Cat6 is actually the standard for the cable. You wouldn't refer to a switch as a Cat6 switch. You would actually refer to the NIC, the network interface card in the switch, as, say, a 1 gigabit switch. So 1 gigabit switch. Any routers, any firewalls, all of their network interface cards would have to allow you to transmit at 1 gigabit. And then all the way up to your internet service provider. Whichever your internet service provider would be, I'm not going to discriminate and name one, they would need to be pushing data to you at that 1 gigabit per second. If you have a bad internet connection and you're only receiving a certain connection speed from your internet service provider, upgrading all of that doesn't mean that your internet speeds are going to be any faster. But if you do have another computer in your environment, or say a server in your environment, that you're pulling data from over your network, and you upgrade all of the interfaces on your own network, then you should see some pickup in that speed. But again, just replacing all of the cable in your environment, upgrading all of that cable and upgrading all of the switches and all of the network interface cards doesn't necessarily mean you'll see the boost all the way up to that 1 gigabit per second. There are other environmental factors such as electromagnetic interference. There's distance factors, there's processing factors that can all slow down the rate at which you're receiving the data. We also want to remember that you can push power over these Ethernet lines, and when you're pushing power over the Ethernet lines, so we'll have our Thunderbolt icon here. When we're pushing power over your Ethernet, we're going to refer to that as PoE, power over Ethernet. So that's our RJ-45 in a nutshell.